Hello everyone, I welcome you all to this class. This is mathematics class, and today we have this topic to study, ordinary differential equation, and we can write in short form ODE. Now before we go into the full study of this, before we even define what ordinary differential equation is, let's first of all understand what a differential equation. We know that we have many equations in mathematics, right? But what is a differential equation? Now, a differential equation is an equation that involves an unknown function. That unknown function, we call it the what? The dependent variable with at least one of its derivative. So, with at least one of its what? Derivative with respect to the independent variable. So, when you're talking about a differential equation, you must have um, you must have a dependent variable, and you must have at least one of its derivative appearing in the equation with respect to the independent variable. So this is the meaning of a differential equation. So, but what is the what is the meaning of ordinary differential equation? Now let's know the meaning of ordinary differential equation. From what I wrote down on the board here, we say that a differential equation containing the derivative of only one dependent variable with respect to what? A single independent variable is called ordinary differential equation. So now let's look at some examples of ODEs, some examples of ordinary differential equation. You can see the first one I wrote here, x prime of t. We read this as x prime. This is x prime of t is equals to cosine 3t minus 5. So this is a differential equation and is an ordinary differential equation. Why is it an ordinary differential equation? Because I have I have the derivative of only one dependent variable. What is that dependent variable? X. X is the unknown function. It is a function of what? T. That is, it is a function of the independent variable. So, and I have the derivative of only one what? Only one dependent variable, which is x. X depends on t. So I have the derivative of only one dependent variable with respect to what? A single independent variable. What's that single dependent variable? T. So this is an ordinary differential equation. Now this one will have second derivative of y with respect to x plus the first derivative of y with respect to x all squared plus y equal to 0. Clearly, in this equation, this equation is what? A differential equation, right? It's a differential equation, and not only a differential equation, is an ordinary differential equation because I have the derivative of only one dependent variable. What is that dependent variable? Y. With respect to what? A single independent variable. What is that single independent variable? X. Because you are finding the derivative of y with respect to what? X. So there's this, because this thing is the derivative of y with respect to x. So we have only one dependent, the derivative of only one dependent variable with respect to only one independent variable, a single independent variable. So let's look at this one. So this one written here can be written as this second derivative of y with respect to x. You can write it as y prime prime. They are the same thing. Then this one, the root plus first derivative of y with respect to x all squared. You can write it as y prime, then all squared, then plus y equal to 0. So this writing is same thing as this one. Then the next thing we have to look at is the third one now. So we have open bracket 1 minus t close bracket y prime plus 3y equals to negative 2. Now we have only one what? The derivative of only one dependent variable. What is that dependent variable? Y. Y prime. Then with respect to a single independent variable, what is the independent variable? T. So this is an ordinary differential equation. So let's look at the second one here. We have y prime prime plus 3y prime prime plus exponential ln x equal to 0. Of course, this is an ordinary differential equation. I have the derivative of only one dependent variable y with respect to a single independent variable x. So, and this one is we have v prime prime of t minus exponential 3t equal to 0. Now, what is the dependent variable there? What is the dependent variable there? V. So we have the derivative of only one dependent variable v with respect to what? A single independent variable t. Now we want to look at the degree and the order of ODE. That's ordinary differential equation. Now the order of ODE, the order of ordinary differential equation, is the order of the highest derivative which appears in the equation. So for you to know the order of a given ODE, you need to consider the order of the what? The highest derivative appearing in the equation. So let's look at the degree of ordinary differential equation. So the degree of ordinary differential equation is the power of its highest derivative. The power of its highest derivative is the degree. So we have some couples of examples given to us here. So we want to consider, we want to know their order and the degree. So for each of the following ordinary differential equations, determine its order and degree. So let's consider them one after the other. So let's find the order. What is the order of this ODE? For this first one, let's look for the highest derivative. This is y prime prime prime, right? This is y prime. So which one is highest? You know, prime prime prime. This is just a notation. We use this Roman numeral, right? This is 3 and this is what? 1. So this is the highest is 3. So the order is 3, right? So that's the order. Let's look for the degree. The degree, from the definition of degree, is the what? The power of the highest derivative, right? So let's look for the highest derivative. That's this y prime prime prime, right? So this, we're having the highest derivative here. Now what is the power of this highest derivative? The power is what? 1, right? So the degree is 1. 1 because you are not having y prime 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 raised to any other power greater than 1. So had it be that you have y prime 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 raised to power 3 or raised to power 2 or raised to power 5, then it means that the degree will not be 1. But if you have y prime 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 and you are not having it raised to any power, then the degree will automatically be 1. For the second one, they say that the order of ODE is the what? The order of the highest derivative appearing in the ODE. So for the second one, the order is what? The order of the highest derivative appearing in the ODE. What is the order of the highest derivative? So let's look for the highest derivative. So we are having x prime prime. Roman numeral, if you have 1 in Roman numeral, this is 2, right? So we are having x prime. You have 1 in Roman numeral, you consider it's 1, right? So this is 2 and this is what? 1. So which one is the highest? 2 is the highest. So the order is what? 2. Right? Let's look for the degree. For the definition of degree is the power of the highest derivative. So this is the highest derivative, right? Because we're having y prime prime 2 in Roman numeral is bigger than what? 1, right? In Roman numeral, right? So this one is having the highest derivative. What is the power? You can see you have this all raised to power what? 2. So the degree is this power of the highest derivative, which is what? 2. So that's an ODE of order 2 and then degree 2. And for the third one, let's look for the order. What is the highest derivative? We are having y fourth prime. So you know IV in Roman numeral is 4, right? Then but we're having y prime. 1 in Roman numeral is 1, right? So 4 and 1, which one is bigger? Is 4. So the highest derivative is what? 4. So that's the order. This is ODE of order 4. Then what is the degree? Degree is just the power of the highest derivative. That's the power of this one. What is the power? So you know that the power here, the power of this is what? 1. Because you are not having y fourth prime raised to a power, let me say 3 or 4 or 6. Do we have such? No. We just have this. This is what we just have. Y fourth prime. So the power of that is what? 1. So for the fourth one, let's determine the order and the degree. Now what is given to us is first derivative of y with respect to x plus first derivative of y with respect to x all raised to power 3 over 2. Oh, this is supposed to be raised to power negative 2. Sorry. Negative 2 plus 2y equals x raised to power 3. So this is what we have. So the correct questions will be first derivative of y with respect to x plus first derivative of y with respect to x raised to power negative 2 plus 2y equals x raised to power 3. So we want to find the order and the degree. We know that the order is what? 1, because the only derivative of y we are having is just first derivative. So the order is 1. Now to determine the degree now. So what is the highest power? For us to get the highest power, we are going to simplify this. Right? Let's simplify it. So we simplify this fraction for us to get the highest power of that first derivative. So for us to get the highest power of this first derivative, we need to simplify it because we are having negative index here. So we want to make that negative index to be a positive index because the degree must be a positive index, right? So let's do that. So for us to do that, we are going to multiply this equation by first derivative of y with respect to x all raised to power what? Positive 2. Because positive 2 plus negative 2 will give us what? 0. And anything raised to power. And any quantity which is not 0 raised to power 0 will give us 1, right? So let's simplify this. So multiply everything by first derivative of y with respect to x all raised to power what? 2. If you do that here, this will be raised to power what? 3 plus then multiply this by first derivative of y with respect to x all raised to power positive 2. Using law of indices, add the power. Negative 2 plus positive 2 gives you 0. So and this quantity raised to power 0 will give us 1. So we are going to have plus 1. Right? This is what we are going to have. Plus 1. The next one is what? Plus. We multiply this by what? First derivative of y with respect to x all raised to power what? All raised to power 2. So we are going to have 2y. So we are going to have 2y multiplied by first derivative of y with respect to x all raised to power what 2, right? Then equal to, which is equal to x raised to power 3 multiplied by first derivative of y with respect to x all raised to power what 2. With this we have multiplied everything by first derivative of y with respect to x all raised to power 2, and all the index or powers of the derivative, they are all what? Positive. Since all of them are of first derivative, and the definition of degree is the power of the highest derivative. So since all of them are first derivative, so we will basically look for the one with the highest power. Which one is this? One have power 2, this one have power 2, this one have power 3. So the highest power is 3. So the degree of this ODE is what? 3, while the other is what? 1. So thank you so much for being part of this class.